Running the ICO 950. Right now there's 155 to 156 volts across the electrolytic. The eye on the ICO 950 is wide open, so it looks to me like I didn't harm the electrolytics. But I want to run a power factor check on it. The power factor should read down to 0 or maybe no more than 10%. Now I can compare it with a new one, brand new one unused in my drawers there to find out. Now, as you saw on the failure video, which by now would be removed, we got the line cord in, cleared the shorts and checked over and over again to make sure we did not have any more shorts on the chassis. Steady 156 volts in there now across the electrolytic. These are rated for 160. According to the schematic, the cathode should have 120 volts on it. That don't seem very much, but that's what it calls for in the schematic. Of course, the radio's off, it's turned off, no filaments are on, and there's no 35Z5 in the socket. The 35Z5 does have a heat of the cathode short, and like I say, I do not have one. I have a very small tube inventory, and all those tubes that were in that box that I got, there wasn't one 35Z5. I mean, you can't expect there are thousands and thousands of tubes out there, and so Bob has an old one he pulled out of a radio. He doesn't know the condition of it because I don't think he has a tube tester. So we'll hook up in McDonald's sometime during the week and he'll give it to me, and if it's successful we'll add it to this part. So this is the start of part 4, and hopefully that will conclude the problem, solve the problem I should say, by putting a new one in there. What I'm going to do is I'm going to pull the 50L6 out of here, the audio output tube, and I'm going to test that. I'll do that off camera to make sure that that did not develop a short. I've had some problems with some of these cheap clip leads, the thinner ones, like these here. Not all of them, but some of the thinner ones. They're not soldered, they're crimped over, and I've had a lot of problems with the cheaper leads. I had about 4 or 5 of them that were bad, and I just pulled the clips off of them and I saved the wire. Threw the damn clips out. I tried soldering them, but they're too small to work on. So the heavier clip leads with the thicker wires are made better. Alright, here we are. We got 154 volts. Like I say, the line voltage is still 119.1 right now. So it went down a little bit. So if I take my meter, and if I'm very careful here, and put my meter back on the electrolytic, easier said than done, me. Alright, we're back on the electrolytic now. You can see where the voltage is climbing. And there goes my damn meter. It's always timing out. It's going to go out, but 155.4 volts right now. That's what I hate about that meter. It keeps ready to shut off all the time, you know. Even though you got voltage on it, it's being used, it still goes out. Alright, so you can see I got 153, 154 volts on that. I'm taking it off the electrolytic, and I'm right off the ICO 950. So in other words, there's no high current draw off the electrolytics. So that tells me the electrolytics are good. Alright, I had forgotten, my expanded range does not work. When I redone this, I could never get, the expanded range won't work, so it's no good above 50 microfarads, so it's reading at the high end, almost to 50. The power factor loss is 10%. Now, on that capacitor, there's a speaker field coil, and then it goes through the speaker field coil. I think it was 350 ohms DC, as I recall, on the schematic. And then it goes to the other half, which is a 47 microfarad capacitor. So we're reading the power factor on both capacitors through that field coil. So that's the way it is. So as you can see here, it's 10%. So there's a 10%, what I call a 10% power factor loss. It's almost like an ESR. And as you move this dial, right in this range, 10%, is where the eye is the clearest. Unfortunately, I threw out the capacitor, and I'm trying to think, was it the Philco that had a 30 and a 50 of this? You know, they don't even list the capacitor value on the filtering supply down here, but I think it's a 30 and a 50. I could be wrong. So I gotta stop and put the camera down, get my microscope eyelet out, and check that. There is no listing for a C20 and a C21, which goes across the field coil, each side of the field coil, which is 450 ohms. You could probably see that right there. But there isn't any C20 or C21 on here. So it's not very helpful. I'm going to have to spin them capacitors around and see what it is. I tell you the truth, I don't remember now. That's the problem when you work on one radio and you do it and then you do another one. And I can't save all the old parts. I tossed out that electrolytic that was in here. So let me check. I know that the input filter was a smaller value than the second filter after the field coil. Normally it's the other way around, but that's the way it was. The input filter is 33 at 160. So we'll get another one out here, and we're going to put this on the ICO 950. This is the exact same lot where I put this one in. And I want to see if that's still got a 10% power factor loss. Of course, we're reading, this is a 47 then. This is a little bit bigger, but that's the way it is. That's the wiring that came out. Well, it wants to close a little bit, and it's down to 0 power factor loss, which is where you want to really be, down here. So as I turn it up, it starts closing at 10. It's good down here. So I don't know if I can check the ESR on that. I guess I can. I've seen guys use the ESR meter right in circuit. I don't think there's a problem. So let's check the ESR on that. And before I do that, I'm going to get the value for the capacitor on here. Now, we're really doing two capacitors, and they're not really isolated except by the 450 ohm field coil. But I think that'll give me a pretty good idea as to what it is. I think they'd probably be okay. In other words, they hold the voltage fine, and so they're not shorted. So let's check the ESR. Okay, we got the electrolytic shorted out now. We got the electrolytic shorted out. So that we'll have no voltage on the caps. We're Definitely shorted out. Okay. Put the ESR meter on. We zero it. .96, but we're reading both capacitors, and we're reading, I don't even know if that's on camera. I think it is. We're reading both capacitors together, so we're reading the 47 and the 33, and we're reading each capacitor through that field coil in the rest of the B plus circuit, but the filaments are not lit, the radio's not powered up. A 0.95. Let's just see what it's supposed to be. Well, it's hard for me to read this. They don't have a 33 here, so a 33 should read 1.6 at 160 volts. Okay, and a 47 should read 1. So if you're parallel, I don't really know how you're supposed to decipher that. But it was 0.95, so I think the capacitors are okay. The real test would be to take them out. If I'm going to do that, I might as well just change them. So I think we're okay on that. We didn't have any problem. We didn't have a high current draw, as I showed you in the video. Okay, so this is all that's going to be done. What I am going to do now, though, is I'm going to test the 50L6. I'll do that off camera, but I'll give you a report on it, just to make sure that that didn't develop a short, and if it did, I do have a 50L6. I just do not have, at this time, a 35Z5 in my stash. All right, tube test good. No grid emission. No shorts. I just went through this. I'll do it again. A little flicker is normal when you're changing switch positions, but not to stay on. Okay. So the 50L6 is good. So that did not get damaged. Alright, I want to show you something. This, as I mentioned in an earlier video, the 35Z5 will not light in this tester. Obviously it uses pins 2 and 7 to light. In the Radio City Products 308 tube tester, the 1940s tester, the tube will light in that tester. Okay? So we know that. It's just a matter of the configuration of the filament pins, what the tester itself uses. Okay? But I want to point out something, that it's got a cathode heater short even though it's not lit. It's a permanent short. Watch this. See that? Okay, I rotate the shorts switch here. Alright. So it has a heated to cathode short. Now, I'm confirming this right on this tester, even though this tube isn't lit. So in other words, it's a mechanical short. It's that bad. Because your cathode carries your AC voltage, which is in this filament string. Your filaments, I should say. And your cathode carries the B+, but they never should be connected. So, I'll pull the tube. Okay. Tube is cold, it never lit. Plug it in, instant short. But I don't have another one, so I can't verify that, but it did not have a short when I tested it in the 308. I can do that, but I'm not going to waste the time to do it. I wanted to make a point that you can have a heated to cathode short so severe that the tube does not have to even light up, and it could have another element short too. It could even have a short from the plate, which is the AC side, to the cathode. You don't know what happens inside these tubes. Okay, so we're going to stop at this point. I got to wait till I get to 35Z5, and if I get it from Bob, tube is good, we'll fire it up, but I'm still going to order another one from Bob Dubush, and I got to order the 12DT8 anyway, so one way or the other we got to order them. Off camera yesterday, you'd never know it, but I used Brasso on this chassis. Doesn't look like I did it? Well, nobody said that I can do this stuff. I never could. There was a little rust right there on the right-hand side, and I used 220 grit sandpaper to get it off. Then I used Brasso. There's a little bit of shine there, but not much. It's not worth painting aluminum paint on it. You got a little rust right here where the back antenna coil goes on. It's not that bad. And in the front here, on the right-hand lower part of the speaker on the chassis, there was a little rust there, I sanded that off, but it's not worth putting navel jelly in there, because then I'd have to paint it. You can't, when you use navel jelly or any of these rust reformers, you got to remember that you have to paint it. And that would mean I'd have to hit it with aluminum paint. It's not that bad that I have to worry about it. You see that wire right there? Well, that's factory. That was done. That's where I grounded my line cord neutral side. Okay, so I think we're okay on these capacitors. And we're waiting on the 35Z5. When I hook up with Bob sometime this week, he got a tube he pulled out of a junk set he got, and we'll try it out. So meanwhile, this 50L6 goes back in. Alright. And when we get a replacement for this guy, we'll be all set. Alright, so we'll come back on this, because this is still part 4, and I don't plan on making a part 5. And then I'll be putting the antenna back on the back here. I got the wires all ready to go here. And there's a ground point right here. Right here hanging off. That goes to the chassis. I had to cut that, left a little pigtail so I can wrap it around the pigtail and solder it. And it's just going to replace the capacitor for the antenna. So that just goes right on the back of that thing. That little slot is for this piece of metal here to go through, and I got the original screw stuck in there so I don't lose it. Okay, we continue on with part 4 here. I met Bob this morning. This is the next day. He got a 35Z5 out of an old junker radio he had. I tested it. Tests very well. Tap is good, so we're not going to be putting a resistor in there. I've got my meter connected to the input filter capacitor. I got to connect up the hot lead yet, okay? And I've got the meter set on AC volts, because that's what I want to monitor. I want to make sure that there is no short. Now, I put this tube in the tube tester, and it did not light up short instantly as soon as I plugged it in, like the other tube did. So we do not have a short on the 35Z5. This one here is a replacement. It's not new. I ordered the 2 used 35Z5s from findatube.com, which is Bob Dubush's site, and the 12DT8 that I also needed. So those are on order, and we're going to try this out. So let me set you up on a tripod here and get this AC, I want to measure AC voltage. I should not get any AC voltage coming into the capacitor. The antenna is not connected, it's still sitting over there. I'm only interested in shorts right now and problems with the tubes lighting and the dial light lighting very bright. We're ready to try this out now. I got my meter set on AC across the input filter capacitor off of pin 8 of the 35Z5. I want to make sure there's no AC coming through. This is the tube I got from Bob. It's not a new one. It tests good in my tester. So what we're going to do now, we got our resistor ready in case we have to put it across pins 2 and 3, but we're not going to do that yet. We're going to flip the variac on. We're monitoring AC voltage in the filament, the pilot light rather. We're at 37 volts right now coming into the line. No light on the pilot light, which is, well, I wouldn't expect it to. Before it was lighting very bright at that voltage. No AC at all on the input filter. Of course, there won't be any DC yet. It's only 0.334 volts. Alright, we kick it up to a little higher, but I'm watching the pilot light and I'm watching the 35Z5. It's not lit yet. We're at 45 volts. No AC component on the cathode. No pilot light lit yet. .1 AC component. 0.1. 0.2. It's climbing, now it dropped to 0. That might be normal. Now it's all 0 on the AC. Let's see if we get any DC. We're getting 28 volts DC. Alright, so that's a good sign. We're only putting in 45 volts and we're getting 28 volts DC. Which is pretty good, because considering the tube isn't even lit. We're watching the AC component as we climb it up to 51 volts. No AC on the DC input filter, and 28 volts, 29, and climbing very, very slowly. No pilot light lit yet. Alright. So, let's put it down to AC again. 65 volts. No pilot light lit. .58 volts DC. Put it back down to AC. .79 volts line input. No pilot light lit yet. And 35Z5 is glowing. .72 volts DC, 73 climbing. No pilot light lit. Could be that I blew out the pilot light. Alright, because I would think that the pilot light would light. But remember, the shunt in this 35Z5 is good. If it wasn't, the radio would not be working. Let's put it down to AC. Nothing. Alright. 88 volts going in. No pilot light lit. No AC. 81 volts DC. The input filter. The pilot light bulb is probably burnt out. I don't know why, because I didn't, I replaced it. A couple of times, I think. Alright, let's check for AC. No AC on the input filter, that's a good sign. Alright, and we'll put it up to 100 volts. Now, I think the pilot light is burned out. Again. .35Z5 is lit, good. 50L6 is lit. 91 volts on the input filter. Now the schematic calls for 120 on the input filter at 117 volts. So we're going to go with 117 volts right now. 105. So we're getting a little less on the input filter than what we normally would get. I was going to put a surge resistor like 22 ohms because that's all I have, 5 watt, but it's not necessary because that'll just reduce that even further. And I'm getting some noise out of the speaker, but there's no antenna coil on the back. So I'm not worried about that. What I'm worried about is any AC voltage, and there isn't any on the input filter. So I think we've got it made. Only 105 volts, and the schematic here voltage listings on the 50L6 we should have 82 volts on the plate, 88 on the screen, and 5.6 on the cathode. I will be checking those voltages. I did not do that yet. On the schematic here, I remember seeing it 120 volts. Where I saw it, I don't know. Okay, here it is. Voltage at 35Z5 cathode, 120 volts. Well, we're only getting 105. That's at 117 volts. We're at 121 volts now. Now the best she'll do is 108. Let's check AC component. None. So there's no AC, so the problem with this radio was the bad 35Z5 tube, which shorted because of that solder glob. Alright, we're supposed to have 4.5 volts across the pilot light. We have 14.5 volts across. I hope you can see that. 4.5 volts across the pilot light. Well, we're not getting that. We're also not getting 120 volts across from the output of the cathode. We're getting 108 right now. We're supposed to have 32 volts across the speaker field, so that's going to be the next test. Alright, we got the speaker field connected up from the high side, the positive side of each electrolytic, as shown here. Here is the field coil right there. C20 and C21. It doesn't give you a listing. There is no C20 and C21 on the list. But that's the filter capacitors, 33 and 47. So essentially we're measuring from the plus of each one, and there's the field coil, and we should have 35 volts. I just turned the radio back on. Alright, we're going to measure in DC here. Roughly about 23.5 volts, and we're supposed to have 32. So we're not getting our correct readings on this for some strange reason, but the radio is making some static. But that's my hand touching the antenna wire, which was connected to the coil over there, and you're picking up this static from this here. Alright, I got the meter back on the input filter, which is the red wire here. There's 108, 109 volts. $121 volts, 200 milliamperes. Now the 35Z5 read good on the meter, so we're going to call this okay. Let's check one more time. AC component on the input filter. Nothing. Okay. So the whole problem with this was the 35Z5 got zapped out by that solder blob across pins 1 and 2 of the 50L6, which is right here. It did not hurt the 50L6. I took it out yesterday and tested it. It was still good. Okay, so I think we're good to go on this. I got a couple of chicken head knobs I'm going to have to stick on here for now, because I don't have anything that'll fit this. Now the pilot light is in the AC. She's climbing. I got the leads across pins 2 and 3 right here. That's strange. Oh, I'm on DC. Oh, what the hell was that? Oh, don't tell me I got silver mica disease on top of everything else. Or maybe I was just shorting these out. When I hear static like that, it scares me. Okay, that's probably what happened. No disaster. I just put a little more voltage on there. B+. Alright, so we're getting 14.5 volts. Now I know that the pilot light is not on. Obviously it got burnt out again. It must have, or there's a bad connection in this socket. But it says 4.5 volts. I would imagine that's with the pilot light in. So let's change the pilot light again, and we'll put this off. Well, the pilot light is burnt out, that's for sure. I just checked it with the ohm meter. These must be made in China. These are the ones I got from Sal's Capacitor Corner. And they're probably made in China. Well, let me put another one in. Yeah, they gotta be made in China because they won't push and twist in. Some of them do and others don't. And I have to order American-made bulbs. Alright, I got a sponge between these two because they shorted out. I think that's what happened. I gotta be very careful I don't short things out here. I always like to use clip leads because when I try to hold the probe in, never get a good reading. Alright. We're in AC because we're across pins 2 and 3 now. Let's see what we get for voltage. Let me flip this on. And what we're going to do is I'm going to be looking at the meter, but you guys are going to be looking at the pilot light right here. Here goes. The initial surge. We're still going to use the Zeners on here. And that'll save the bulb. So let's just see if that still goes up to 15 volts. Still getting pops and crackles. 5.2, that's a lot better. But look how bright that is. That sounds like silver mica disease to me. Now these are large IF cans, so I don't know if they're subject to silver mica or not. Electrolytic is okay, it's not running warm. Alright, 5.2 volts. That's still under 6.3. Now that's AC. DC, you're really not going to get an accurate reading. It's only 1.2 volts because it's across the filament, part of the filament shunt that's built into the 35Z5. So you want to be on the AC scale for this. So it's not bad. It just looks much brighter than it should be. But the meter don't lie. Alright, I got a 22 ohm resistor, 5 watt, across pins 2 and 3. Let's take a look at the pilot light when I flip on the radio. Now that's a lot better. It's very dim now, but let's just see if it comes up. That eliminates the surge. So when the Zeners come in, I guess they will do the same thing. We can't go by the meter here because it's not connected up, so we turn that off. That's not bad. Very slightly warm, lukewarm. I got the lights off in the shop. That's not a bad glow. I think in a darkened room this will probably show up okay. I can tell better once the radio's in the cabinet. Okay, we'll continue on this when I get the Zener diodes, and I will be putting them in off camera. I'm not going to be doing my soldering and struggling on camera. We'll put them in between 2 and 3, and we won't need this resistor. Then I think we're setting pretty good. Alright, I just came back from the post office. Jim Asbell sent me some Zener diodes. I looked them over with the iLope magnifier, the lighted one, and these are the numbers that I got off of them. MK like in Michael, Kathy, MK, then under that is P6KE, P6 King Edward. 7.5, that's probably the voltage, because Jim told me on the phone that would be a good one to use. That he has a bunch of these. And then under that is 8435. So he gave me a bunch of them on a card here. So what I'm going to do now is clip them onto the radio. Jim said to either put the cathodes together or the anodes together. It doesn't matter. So we got a little bit of a congestive mess here. We got to move some wires out of the way from the meter here, because we're not using the meter on this. And we're putting this up here to keep the leads from shorting out. So, okay, what we're going to do is we'll put the cathodes together. So we got the band facing this way. So we're going to have the band facing each other. So we're going to go like this. Alright, and then we're not doing any twisting or anything else yet until we put these on clip leads and see how it works out. Alright, so the band on this one here is going towards the band on this one. So I guess you could see that. If you can't, well, I'm sorry. What I did is I turned the switch off on the radio because I want to see if this light's bright. And we're making sure that we're not having a problem with shorts out here. So we got the radio switch off, put the variac on. We're going to bring it right up to we're going to bring it to 118. We had it on 121. We were getting 109 B+. These radios were designed to run on 110 or 117. Oh boy. We touched the damn wire. Good thing I didn't turn that on yet. We don't have a very good system here at all. Not a very good system at all. Let me lay a pliers over there so I can keep these wires away from the chassis here. Alright. Let's turn this on and we'll keep an eye on this. Still a little flare up, but not too bad. Not as much. And as you can see, we're fine. Now I don't know how well these would work if the shunt in the 35Z5 burnt out. I don't know what would happen to the Zeners. Whether the radio and the pilot light would continue working as long as the rest of the 35Z5 is good or not, that I don't know. But yes, it's pretty bright. It is pretty bright, but it don't look excessively bright. So let me stop this a minute. I'm going to try to put a meter across this and see what the voltage is across the pilot light. Alright, let me see if I can get my clip leads on there without disturbing things. We're set on AC. .37. That's pretty darn good. Alright, it's a crummy job as always, but it's in there. I had to tack it in here, and that was a hairy job keeping these other wires from popping off here. Twisted together and got it on there. It's not going to short out. There's not much I can do. I can put a little heat shrink on the end of this probably and heat it up, and that should take care of that. Alright, let's try her out. Alright, I'm getting 4.36 volts across pins 2 and 3. The pilot, as you can see down there, looks fairly bright, but it's not going to burn out. And what we're going to do now is put a clip leads on this. That's what we're reading this interference here. We're going to put a clip lead on here and temporarily connect up this loop coil here. All right, we unplugged the dehumidifier now so we can hear something.
And they were throwing in traffic at one point.
Well, all right, well, that I get. I mean, I thought it was just like swerved and hit something. Yeah.
Oh, they distracted me. Is that Mark Scott and Dodge Phantom or whatever you drive?
Well, the rubbing voice coil is a problem.
Brad in Middletown. Brad, what's up? Hey, guys, how you? Welcome,
Percent more likely to stay with your company longer. Hire better, hire faster. Start your free trial today at glassdoor.com/hire.
You can retrace the steps of a hero.
The 17th annual Tunnel to Towers run is Sunday, September 29th, honoring firefighter Stephen Siller, who ran through the Brooklyn Battery Tunnel and was killed on 9/11. Come run or walk. Proceeds benefit programs for...
Okay, so the radio is working.
Family.
There's an after-run block party with a concert and food.
Go to tunnel2towers.org.
All right, I put a little heat shrink on the twisted ends of the Zenas here. So I'm going to go and put the back on now. And that's probably going to conclude it, because I still have to polish up the cabinet. And I'll probably have to get some knobs. For now, all I got is, I think I got a couple of chicken head knobs I'll have to stick on there. That's all I've got. Okay, we're going to plug it in. We got the Variac set at 118 volts. Lousy tack soldering job on the antenna coil. What else is new?
You go to the RWJ Barnabas Health Telemed app, and you get to see the doctor right away, whenever you want, wherever you are.
Well, the speaker sounds horrible, but there's nothing I can do. I can't recone a speaker.
No appointment necessary for access to doctors who all meet our high standards. In fact, you can even see physician profiles and read about doctors who fit your needs. And
Sometimes you can put a wad of paper in, like tissue paper or toilet tissue, a little wad of it in the back and push on the cone and leave it in there. Sometimes that works.
the App Store, or visit rwjbh.org/telemed. Now you can see the doctor even when you can't go to the doctor. RWJ
It looks like the whole cone is
healthy together.
bad. All right.
Fall is approaching in New York. Time to take full of the nice weather and save yourself time by parking with Spot Hero. Just download the Spot Hero app, type in your destination, and reserve your spot. Use promo code 880 on the app to save $10 off your first park. Spot Hero, park smarter. 142 at WCBS. Now sports
Okay.
first, here's Rick Ackerman.
And Michael Pete Alonso has been more than a rookie revelation.
Let's see if we got 10-10 wins here, somewhere in here. Oh, I'm going the wrong way.
Today, 4 games out of Newsmaker. I'm Larry Morgan, and with me is Karen and Brian Holloway. So, Karen, we've been talking to you for a while now about Lone Star Transfer and how you and your team can relieve people of that crushing fight.
Well, no, what that is. Chicken head knobs are not exactly easy for tuning a radio. I would say that radio's working pretty good considering all the noise I got in the shop here.
Today for a free consultation so we can get your specific needs and make sure that we can get you out of that timeshare.
Well, it's not my local station.
What a timeshare owner can... phone and say that
Brian Holloway, you had anything to add here?
It happens. Sometimes
Okay,
when you
I had to turn the radio
transient who's from
and
another
shut off the
town
lights.
who just is driving through. You just do not know. But those two kids did the best they could, and they even had some kind of identification. And they went right and told their parents, which is the thing to do. How about this sentence, though? Stonington women on the Waterford Country School staff.
Yeah, that speaker is,
got 6 months.
it moves in and out good, but the voice coil is
6 months, is that
rubbing
enough?
badly.
Of course, she's apologized and admitted everything, but I thought that was kind of a light sentence. 12 minutes before 2 at WICH. A lot of things in the news to talk about, good, bad, and ugly. And we'll be right back with you. Stick around and get some tunes and some more conversation.
Norwich Coin and Jewelry, always nice, and we do free.
All right. That concludes part 4 of this radio. So this is a very long video. I know it is. I can tell by all the clips I've been putting in here. So for now, I'm going to leave it out of the case and make sure I protect the speaker until I get the case clean, because I want to work on the polishing of the case. I got the Brasso. I haven't tried it on here yet. I still got to get the wax, and they're going to have to wait till next week for that. I just have no choice. I got to wait till next week. I am not having any luck around here. I haven't tried the automotive stores. But I have no luck getting anything that people are recommending here, except, of course, through Amazon and everything else. And again, that will have to wait till next week. So there's no point in putting the radio in the cabinet, because when I try to polish this up, using the Brasso first and then whatever polish I can put on here, I want to do it with the radio out of the cabinet.
Updated on all of the local and national news. So keep it here at WICH AM 1310. It's a pretty good day for standing on the corner, watching all the girls go by. Dean Martin, you rascal.
All right. That's it, folks. Thanks for watching. Radio's working fine. And so that shorter tube will do a lot of damage and cause a lot of aggravation. Take care, everybody. This concludes part 4.